Hello grade 8 learner! Welcome to another video lesson in mathematics. In this video lesson, we will be discussing about how to add rational algebraic expressions with dissimilar or different denominators. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. Happy learning! This lesson is based on the K-12 curriculum learning competency. The learner performs operations on rational algebraic expressions. By the end of this lesson, you, the learner, should be able to follow the steps in adding rational algebraic expressions with dissimilar denominators and to apply appropriate factoring techniques in adding rational algebraic expressions with different denominators. We begin the lesson by reviewing the process of adding fractions. Given 2/3 and 5/7, we see that both fractions do not have the same denominator. Can we still add them this way? No, we cannot, because 2/3 and 5/7 represent differently divided whole numbers. We have to make these two fractions represent similarly divided parts so that we can add them properly. Therefore, we change the dissimilar fractions to similar fractions. We do this by first getting the least common denominator, or the LCD, of the denominators 3 and 7. That would be 21, which will serve as the common denominator for our fractions. Now, once we change our denominator, we also have to change our numerators based on how we are going to change the denominator. So looking at the first fraction, we notice that 3 can become 21 by multiplying 3 by 7. This means we should also multiply the numerator 2 by 7. In the second fraction, we also notice that we can turn 7 into 21 by multiplying 7 by 3. So this means we should also multiply 3 to the numerator 5. After changing both fractions to their equivalent and similar fractions, we then add the fractions by adding the numerators and copying the denominator. This gives us an answer of 29 over 21. Take note of the difference between this process and the process of adding fractions with similar denominators. If we add rational algebraic expressions with dissimilar denominators, we follow this formula. A over B plus C over D is equal to the product of A and D over the product of B and D added to the product of C and B over the product of B and D. This results to AD plus CB over BD, where A, B, C, and D represent polynomials, and where B and D are not equal to 0. Take a look at the following example. Compare the solution to the solution in adding fractions with dissimilar denominators. Let us study the process of adding rational algebraic expressions with different denominators by an example. Given 5 over x and 7y over x plus 3, we are going to add these expressions by first checking if they have common denominators. Here, we see that the denominators are not the same. Just like dissimilar fractions, if the denominators of the RAEs are not similar, then we cannot add them as they are. We have to change them to equivalent RAEs with a common denominator, and that's what we're going to do on our next step. If the expressions are dissimilar RAEs, we make them similar by solving for the least common denominator or the LCD. We do this by comparing the factors of the denominators. For the first denominator x, we have x and 1 as its factors. For x plus 3, we have x plus 3 and 1 as its factors. Take note that x is a term, not a factor, in x plus 3. To get the LCD, we copy any common factors as well as those which are not common. So in our solution, we copy x and x plus 3. This means that the LCD for our expressions is x times x plus 3. Now that we know the LCD that we can use as a common denominator for our RAEs, we then now rewrite the RAEs into equivalent expressions which have a common denominator. Remember that the LCD for our RAEs will be x times x plus 3. So we're going to change the denominator of our first RAE to x times x plus 3 by multiplying the factor x plus 3 to the original denominator x. But if we change the denominator, we should also change the numerator in the same way. So since we multiplied x plus 3 to the denominator, we should also multiply x plus 3 to the numerator, which is negative 3. For the second RAE, we are going to multiply x on both the numerator and denominator, since x is the factor needed to make the denominator equal to the LCD. If you do this process correctly, the result would be the following expressions. We now proceed to the next step. Now that we've changed our rational algebraic expressions to RAEs with a common denominator, we can now apply what we've learned in adding RAEs with common denominators. What do? We add the numerators and copy the denominator. We combine similar terms in the numerator, then add them to get the resulting expression, which is x minus 9 over x times x plus 3. The final step in adding rational algebraic expressions is of course to simplify our final answer. So from our previous step, we have x minus 9 over x times x plus 3. We check if there are any common factors between the numerator and denominator that we can cancel out. However, we see that there are no common factors between our numerator and denominator, so what we can only do is to multiply the factors in the denominator. We then write our final answer as x minus 9 over x squared plus 3x. Did you follow our discussion? Let's study another example. For this problem, we are going to add 3 over 2y plus 10 and y squared plus 2y over y squared minus 25. Our first step will always be to check if the RAEs that we are given have common denominators. It is always important to check what we are solving. We see that in our given RAEs, the denominators are not the same. So we move on to the next step. We then solve for the least common denominator that we will use as the common denominator of our expressions. We do that by comparing the factors of the denominators. For the first RAE, we have 2 and y plus 5 as the factors of 2y plus 10. For the second RAE, we observe that y squared minus 25 is a binomial which is a difference of two squares. Thus, we factor that as y plus 5 times y minus 5. We observe that y plus 5 is a common factor between the two denominators, so we copy that as one factor, together with the other factors 2 and y minus 5 to form our LCD. Now that we've solved for our LCD, we now change the RAEs to their equivalent expressions with the common denominator. Remember that we use the LCD as the common denominator of our rational algebraic expressions. So for our first RAE, we have to choose carefully the expression we are going to multiply to the numerator and denominator. It helps if we rewrite our denominator in its factored form, so that we can know which factor is still missing based on the LCD. Looking at the denominator of the first RAE, we see that the factor that will complete the LCD is y minus 5. Therefore, we multiply y minus 5 to the denominator and the numerator. Next, let's take a look at the second RAE. Just like what we've done to the first RAE, we rewrite the denominator into its factored form, and from there, we see that we need to multiply 2 to both the numerator and denominator to make the RAE similar to the first RAE. Do you see now that our expressions have the same denominators? After multiplying the expressions in the numerators, we have the following similar RAEs. Again, it's best to leave the denominators in their factored form to make it easier for us to simplify later. Now that we've changed the rational algebraic expressions to RAEs with the same denominators, we can now add the numerators together. Again, we do that by combining similar terms and adding them so that we get the result, which is 2y squared plus 7y minus 15 over 2 times y plus 5 times y minus 5. Finally, we simplify our answer. To do that, we need to factor out the numerator so that we can check if there are any common factors with the denominator. Applying the factoring method for quadratic trinomials, we have the factors 2y minus 3 and y plus 5. We see that y plus 5 is common in the numerator and denominator, so we cancel that out. This leaves us with 2y minus 3 and 2 times y minus 5. Multiplying the denominator gives us the final answer, which is 2y minus 3 over 2y minus 10. Don't be tempted to cancel out 2y because we only cancel factors, not terms. Good job for following the discussion. If there are some things which are not clear to you, you can always replay this video, read your module, or ask help from your teacher to improve your learning. Before we end this lesson, practice what you have learned by solving this problem. Add 9 over x squared minus 9 and 6 over x minus 3. Pause this video and solve before we proceed to the answer. Done? If your answer is 6x plus 27 over x squared minus 9, you got the correct answer. Good job! If you have a different answer, you can check from this solution to see where you went wrong. Remember, mistakes are never permanent if you take the time to correct them. Congratulations for finishing this video lesson. We hope that we have made things clearer for you. Now, it's up to you to determine how much you have really learned because as the US President Harry Truman said, it's what you learn after you know it all that counts. Keep on learning, dear learner, and we'll see you again in our next video lesson.